Okay, hello everyone. My name is Vadim. I work at ETG and I am currently lead the front-end team. I mainly work on improving front ops, DevX, and other technical areas in the transport product department. So, what are we going to talk about today? Not long time ago, we had a typical situation. With one of our products, something broke. Following best practices, we turned the service off and on again, but it didn't help. It also didn't help that there were no errors in Sentry and we didn't know where to look for the problem. Only after some time we found out that the problem wasn't with us at all. One of our teams that depended on our service through a common integration layer released an update. Their CPU usage suddenly increased and this affected our system, without us noticing. This story made me think, how can we really know that the product works and works properly? Recently, our team launched a new product, Car Rental. The service is available for B2B partners and corporate clients. When launching this service, I decided to approach this problem more thoughtfully. So, how we can know that the product works and works properly? The simplest way is to type the application address in the browser and see that everything works. Pages open, requests are sent, and go on. But you'll agree that checking the application this way every time is impossible, especially when support comes to us and say everything is broken. In this case, there is no point in checking anything. We're already down and losing money. We want something that, instead of support or clients, will tell us in time that something is going wrong. And you, developer, should take a look before the application crashes. As you might guess, I am talking about the three pillars of observability: metrics, traces, and logs, based on which we can understand what's happening with our application. So, now we will learn what is observability and what is monitoring. What are the key differences between them? What's the metrics and what types? Are there pure technical metrics? How SLA different from SLO and SLI? And what is an observability passport and how does it help? So, let's start with the basics. What is a metric and what types are there? Let's start with a simple definition. A metric is a numerical indicator that measures a certain aspect of system operation. For example, page load time, number of errors, or percentage of successful requests to the server, and go on. Metrics help us measure, understand, and improve our applications. What types of metrics are there? For example, technical ones. Technical metrics describe the internal processes of the system. They are most often needed by developers to understand what's happening under the hood of your application. For example, CPU usage, RAM usage, response time, and go on. There are also business metrics that show how efficiently the application helps achieve business goals. For example, conversion in purchase or registration, user retention, or for example, revenue per user. But there are also metrics that are difficult to attribute to one category because they affect both technical and business sides. They are also called hybrid metrics. For example, performance and page load speed, the well-known Web Vitals by Google. On one hand, metrics describe purely technical characteristics of your application, page load speed, reaction time, etc. But in the end, all this affects SEO, user experience, and ranking in search results, which can affect your business wallet. Or for example, the number of errors in the system. Frequent errors annoy users and increase the load on support, and can affect business metrics, such as user retention. Another good example of hybrid metrics, which lay between developers and business, can be reliability and availability metrics. SLA, SLO, and SLI. This set of metrics focuses on measuring fulfillment of commitments to deliver high quality, reliable, and stable services. What does it mean and why is it needed? So, SLA, Service Level Agreement, is an agreement about providing a level of service made between business and development. For example, programmers commit that the service will be available 99.9% of the time during a month. SLA in this case is used as a formalization of business expectations. SLO, Service Level Objective, is an internal goal related to system reliability. SLO defines more detailed indicators that developers focus in their daily work. For example, API response time should not exceed 200 milliseconds for 95% of requests. SLO helps technical teams focus on what is important for their users and set realistic benchmarks for monitoring. SLI, Service Level Indicator, is directly a metric that measures the fulfillment of SLO. This is a numerical indicator based on monitoring data. For example, if SLO says that 95% of requests should be proposed in 200 milliseconds, then SLI is the percentage of requests that actually fit within this time. How do these metrics help to solve problems? Reliability metrics help developers evaluate the current service level. You know exactly how your performance goals match reality. They help prioritize tasks. For example, if the availability level approaches the SLA boundary, this is a signal to immediately address the problem. And help communicate with business. SLO metrics allow you to talk to business in the language of goals and priorities, explaining how technical problems can affect users. A special place in working with SLO is occupied by error budget. This is a concept that helps establish a balance between stability and the speed of implementing new features. How does it work? Error budget is the allowed level of deviations that you can afford to stay within SLO limits. For example, if your SLO is 99.9% of trackable time, then your error budget is 0.1%. What does error budget affect? First, it determines priorities. If error budget is almost exhausted, the implementation of new feature is frozen, and the team focuses on solving problems. Therefore, error budget can be used as part of sprint planning and to avoid chaotic switching between tasks. Second, it simplifies decision making. For example, you can explain to business that implementing a risky feature now is a direct path to violating your SLA. And third, it helps find balance. If error budget is not exhausted, the team can safely experiment with new features without fear of breaking production. And you have already noticed that collecting metrics is not enough. This is the main difference between regular monitoring and observability. Metrics should be monitored dynamically, anticipating trends and proactively acting to prevent negative outcomes. When you have just set up monitoring, you can answer the question: is the system working as expected? You looked at the metrics, yes, requests are going through, no errors, and if the load is increased, monitoring will show you an alert. But if your system has the property of observability, then you can already answer the question: why does the system work in the way it works? For example, after launch time, the load increases, and during this time it's better to not release anything. And this will help you more when you're analyzing complex incidents. In the end, monitoring helps understand that something is broke. Observability helps figure out why it's happened. So, now that we know everything we learned, let's return to our main question. How can I understand that product works and works properly? Now we know that this question consists of two parts. How to understand that it works, the part related to monitoring, and how to understand that it works properly, the part about observability in general. When I asked myself this question, I thought that I needed just a page in Confluence, or a folder with bookmark from where I can see everything that I want to know, about my application, of course. Without overthinking, I call this list of links Observability Passport. So, what's inside of my observability passport? The first things I set up was, of course, an error tracker. In our case, it's Sentry, but it can be absolutely anything. Whatever you like, even a simple console log. The main thing is that this solution should let you understand that something went wrong and you know how to fix it. Next, after finishing with the monitoring part, it's time to think about observability. Would it be enough to close the question of errors by catching and analyze them? Analysis is good, but still setting up work in such a way that errors do not occur at all is another level. How to achieve this? Obviously, conduct analysis before an error occurs, and that means we need to analyze the code itself. The range of tools for this is simply huge, from basic linters and test runners providing cut coverage metrics to static analyzers detecting vulnerabilities in the app and its dependencies. And if test and coverage are more about monitoring, then finding and analyzing vulnerabilities is more about observability. One of such tools that allow analyzing found vulnerabilities, which we use, is the Defect Dodger. Defect Dodger offers many metrics to get visual information about trends and insights of vulnerabilities in your organization. Similar to 99.9% availability targets, Defect Dodger set SLA specifically for resolving issue based on their severity. In our case, obviously, the SLO for the number of critical vulnerabilities in production is 0, and the time to fix already found ones, 7 days, which by the way Defect Dojo suggests by default. Then, based on the criticality of the found problem and the basis of your agreements in the team, the problem is taken into work and should be fixed within a certain period, which corresponds to your SLA. Alright, analysis tool vary, but the main idea is using SLAs to manage application stability, like API availability, sentry errors, or code vulnerabilities count. It always comes down to the following set of actions. Identify area to monitor, API errors, vulnerabilities, and go on. Define error boundaries, what deviates from normal behavior. Set an error budget, acceptable tolerance level. Collect your errors, metrics, and go on. Visualize data in dashboards. Set up alerts as needed. And assign owners and define response protocols for incidents. Of course, the observability passport will not be complete without collecting basic metrics, such as memory consumption, CPU load, or others. In our case, provided by the Prom client package. And it will also not be complete without informative logs from our application. As logs are records of events. They are easy to create, for example, a simple console log. Logs give us detailed information about specific types of events that interested us. For example, logging all requests that come to our application or that we make. But logging as a rule happens only within one component of the system for which we are responsible. We write our frontend application, therefore we can add logging only here. The backend might be the responsibility of the completely different team, and they may write logs at their purpose. But as you understand, there are cases when errors occur and one component of the system is not enough. The reason may be much deeper to understand, and you need the whole picture. This is where traces comes to help. Traces are similar to logs, but except that it is a summary list of all events from all involved components. Often, to ensure the correct output of logs from different components, they use some global identifiers that allow tracking the path of the request to all components, like request ID or session ID. And to collect all this beautifully into a nice graph, you can connect tools like OpenTelemetry plus Jagger. Next, another related concept of logs is profiling. Like logs, profiles are records of some events within one component. Only profiles use the most detailed information about what is happening under the hood. Most often, profiles are used to analyze bottlenecks along the path of your request. The part of the request that takes the longest to execute is most likely can be optimized to speed up the time of your entire request. For profiling, we also use Sentry. We look at similar dashboards, we see which endpoints and pages work the longest, and dig into profiles for improvement. Okay, updating the passport. And the cherry on top is, or pie, is product analytics. How users use your application. That's it. You choose events in your application that you want to track, and based on them, you build a typical usage scenarios for your application. Then, together with your product owner, you decide what this means and how to improve the user experience so that they make a decision to buy your product faster. Even though product analytics is as far as possible from the technical indicators of the application, we managed to catch several cases in practice for not properly working components. For example, the currency switching event generated an extra trigger, and we realized that the component was not working correctly. Or, for example, an event that should only trigger on the listing page, for some reason it was sent on the booking page. We also figured this out and found a problem in the cache. And that's basically it. We add to the passport the SLA for availability, which we talked about earlier, test coverage, and Swagger. And my passport is ready. Now, having such a passport, I can centrally find out domain of my application for a quick checkup. I can track errors by their name, see the number of events for a certain period, and receive detailed information. User data, browser, call stack, request responses, and go on. I can collect and analyze system logs for quick identification and resolution of problems. I can receive real-time indicators of performance and system status, response time, error rate, or resource usage, and etc. I can see the number of potential vulnerabilities, assess the risk, and take proper action. I can see metrics collected directly from the container, such as the amount of memory used or the number of open connections. I track which service characteristics, like availability or latency, have SLO defined and monitor their performance against those targets. I monitor the error budget aligned with SLO targets to balance reliability with feature delivery. And I can see the current percentage of code that is covered by unit tests. And I can see the current Swagger describing the API for other services. And that's all. That's all from my side. Thank you for your attention. Help you this observability passport also will help you building your applications. Bye.